So hello everyone, welcome back. I hope you had a nice jolt of energy in the coffee break. It's time to get started. As a reminder, this is a tools in action talk, a bit shorter than the other talks, about 30 minutes, so I'll be a little bit more alert than the previous talks. So I'm Robert, this is Apache Sling as an OSGi-powered REST middleware. Let's start by finding out a bit more about each other. I work with Adobe Systems in Romania, part of Adobe's digital marketing cloud. A lot of my work is based on some open source projects that you see there. Apache Sling is not coincidentally the one that I'm going to be talking about today. And when I'm done with working, doing stuff at work with open source, then, well, I go back in the evenings and do some other open source stuff. It's developer-related tools, bug trackers, code review tools, Eclipse plugins. I would like to find out a bit more about you so I can sort of estimate how technical should I go into some areas. So who in here is familiar with OSGi? Okay, way more than I expected, that's great. How about NoSQL databases, Redis, Cassandra, Mongo, Couchbase? Okay, way more time for other stuff. So today's agenda is the following. We're going to find out exactly what Apache Sling is, some quick facts and figures. We're going to have a special guest, Barry. You'll see more about him later. Then we're going to have the first demo, which will show at a high level how Sling works with NoSQL databases. Then we'll try and draw some conclusions out of that demo and see why Apache Sling is such a good fit for NoSQL databases. A second demo just for fun, and we're going to touch a little about what else is there to Apache Sling besides what we've seen in the demo. So, as some history, Apache Sling is, well, obviously an Apache project. We've entered in about 2007. We joined the Apache Software Foundation. This year we had release number 8, and given the history that we had before that, we're about 10 years old as a software project. Okay, so what about Sling? Okay, Apache project, where you can see the evolution of our code base in time. We have a lot of Java, so it's basically a Java project, and apparently a lot of Maven build files, 9%. I think that's a bit too much, but anyway, that's what you get for using Maven. We had a steadily increasing level of activity, and this is what I call the lucky screenshot. It's a graph of Apache projects using Subversion and how many commits per day they have. The single day that I visit this page, Sling is at the top. So I take this screenshot, it's nice for presentations. Joke aside, Sling is a pretty active project amongst the Apache ones. Okay, so what makes Sling interesting for us as web developers? Well, there are 5 pillars, we call them, of Apache Sling. So it's REST-based. We're going to see a lot of that today. It's powered by OSGi, and we're going to see throughout the talk why that is important. I'm not going to touch on content-driven and scripting inside because there isn't really enough time. And it's an Apache project. Okay, let's start with the simple one. Why is it important that Sling is an Apache project? Well, the Apache Software Foundation is a very neutral home for open source projects. It's where the big companies come to collaborate. So you can be assured that there is no very strong influence from any company on such a project, that it's all balanced and community-based. And by definition, the code is open source licensed under the Apache 2.0 license, which is a very friendly open source, business-friendly, let's call it, open source license. REST-based. So everybody talks about REST. I think that 7 or 8 years ago, everybody was talking about Agile. And if you're not doing Agile 7 or 8 years ago, or if you're not doing REST today, there's something awfully wrong with you. So everybody says they're doing REST. But let's see how a typical approach to doing REST would be in a Java application. So there's this nice cloud diagram. If you have some routes or paths in your application, you would typically define them somewhere and then have some controllers which work with them. So for instance, if you would have a root path, which is the entry point of the application, you would go with the home controller. And then the blogs, you would have a blog list controller, and then you would have some sort of placeholder which serves all your application, all your blog posts, and you would have a blog view controller with that. And well, I would argue that that's not necessarily the basis for good REST design. And well, the reason is that in REST, it's very important to have all the resources identified, exposed in a consistent manner through HTTP space, through a URL space. And well, in here, you're just doing some sort of manual pickup. You're constructing your routes without having a really strong link to your content model behind. And this is where I think Sling can bring a lot of value. Now, in Sling, you have the central concept of a repository. Now, a repository, simply put, is a tree. You have all your data stored in a hierarchical manner, and that is composed of resources. So you have a root, and then you have children of the root, and children, and so on and so forth. And they are all mapped through a single controller. But the most important part is that when you create your application, you already design your URL space. So just like you are, not by coincidence, by design, these resources are perfectly created to be exposed through URLs. So all you need to do is append .html, and you already have your URL space designed. Next up, so we have this repository, and Sling offers lots of abstractions to help you expose those resources over HTTP. So by default, you have servlets which expose them using JSON, XML, HTML, and so on and so forth. And many applications use them, the JSON and the XML renders out of the box, because they're quite flexible, and 99% of the time, they do what they have to do. Well, on the other hand, for HTML, that doesn't always fit. You probably need a very customized rendering for each component type that you have. So Sling offers an additional abstraction, which is called a resource type. So you can see on the right, it's the structure in your repository, and then on the left, the resource types. So the resource types actually are special instructions for Sling and say, hey, you need to handle this in a different way. The Sling redirect one, well, unsurprisingly, sends a redirect to the client. Typically, you do this at the root, so you would send the client to the page where it should end up. And then, if you want to differentiate between the blog list page and the blog details page, you just have different resource types. OK, it's time for our special guest. It's time to meet Barry. 1, 2, 3. Yes, well, this is Barry. In case it's not very clear, he's not a real person. And any resemblance to technical architects, are for living or dead, is purely coincidental. So Barry has two main qualities. First of all, he's buzzword-driven. He knows all the latest NoSQL databases, the latest JavaScript frameworks, is on top of Hacker News. And, well, that's a good thing, right? He's informed. Now, the second thing is that he has a very short attention span. These two things put together aren't so nice. And it just happened that we are coworkers at Acme Software Company. I develop a technical software blog, and Barry is sort of the technical architect. So while he was on vacation, I took a little time, rewrote the blog in Apache Sling, because I know what a great tool it is and how productive I am with it. Well, when Barry came back, he had a shock, obviously, and said, no, we can't have this. We need some solid storage. And said, let's use Couchbase. And I said, Couchbase? Couchbase. And I said, OK, that's a fine persistent project. Let's use that. And then the next morning, he became concerned that we are not able to cope with the humongous number of comments. So he said, use Mongo. OK. Mongo? Mongo. Next morning, he had another concern, obviously. He said, well, the static resources from our application should be served much faster. Let's put them straight to the disk. And so I did. And the next morning, he had another concern, but this time I was ready. I had a laser pointer. And he's chasing it as we speak, and I have a little breathing time, so I'd like to go through a little demo of the blog that I wrote. As you can see, I'm not that great on design, but here's the blog. It has a list of posts. You have some excerpts, some snippets, and you can access the blog details. And there are some comments. And is that, well, you don't have to read the exact details. And you see the comments. Nothing extremely complicated. Well, unless you consider that you have 3, even 4 persistent systems which come into play. A fair remark is that you can do that without a framework. You can do that probably with any framework. But what would be really interesting to see is how Apache Sling allows you to structure your data in a transparent way, so you don't really have to care where it comes from. Let's go one level under the hood and look at how the JSON output from Sling appears. So I don't want XML, I want the JSON. And well, that's a large lump of text. Sorry, I meant this one. Now this is just asking for the JSON rendering of the content block page and going 5 levels deep. Okay, that's better. So scrolling up a bit, you see we have the comments for the Hello World post, and then we have a number of comments with some properties. And then come the images, which come from a different source. They come from the file system, but they appear to be they appear just like the other resources, just like the comments. We have Bootstrap and some fonts and so on and so forth. And we actually have the posts, which, well, they have a large chunk of text. So I've tried to show how this hierarchical nature of Sling comes into play, and now you see that these resources appear to be the same to the client application. Let's see how these are stored. So I mentioned blog posts are stored in Couchbase. Here's a little query which goes straight to the Couchbase API through a view. And you can see these are the rows returned, and they have some Couchbase technical fields, the ID and the key. And then there's a value object which contains 2 things. One is a data nested object, which has the actual data which goes to Sling. And then for lookup, we have the path of the object and the path of its parent. And the ones below are the same. So Mongo. These are the comments that we stored in Mongo. More or less look the same. There's this ID, which is the MongoDB primary key. And if you want to look in more detail to an object, it has the same parent path and data pattern. And that's the file system view. Okay, so what had just happened? In Sling, we have this repository abstraction that I mentioned, which allows sort of like if you have a Unix operating system or something similar, you have a concept of mounts. There's a root, and then in various places in the hierarchy, you can have different mounts. Sling is pretty similar. So we have a root mount, let's call it, which is a JCR mount. We'll get to that a bit later. And then at various points in this demo, we have something else. We have the images, we had a file system, the blast in Couchbase, and the comments in Mongo. So how does Sling internally manage this? Well, the SPI, the service provider interface of Sling, is a resource provider. It's an interface. It has two methods basically to implement how to get a resource, how to list its children. These are produced by a factory. Now, the factory is an OSGi component. It gets pushed into the service registry, and it gets picked up a bit later. And these are some of the production-ready provider factories that you have in Sling. The NoSQL ones you saw, the file system, and the JCR is also there. So once you get from, you have the SPI defined, then it all gets wrapped into an API, which the clients can actually use. And that's the resource resolver, which is sort of the bread and butter of Sling. If you're working with Sling applications, you get a hold of a resource resolver. So how do I get from an HTTP request to my resource resolver? First, it all started with an HTTP request, right? So you have this GET request to a resource, and then you have to find out which resource this is. Because Sling is pretty flexible about what it stores, you can't be sure about whether this is the content blog post hello world resource or a JSON file at that very same location. So you have the resource resolver coming into play, and it picks the resource. In a similar manner, you need to find out which servlet or which script handles your request, which is what the servlet resolver does. And then finally, your custom servlet or script is invoked. So how do I use a resource resolver? Well, I mentioned that we have a sort of a path-based access in Sling. So there are no numerical IDs, no UUIDs. We have paths. So instead of doing a select for a primary key, you would get a resource from a path. Something that may be of interest is that while typically IDs in databases are scoped per table, we have the paths are scoped per repository, obviously. If you would like to read resources that are tied to a shared parent or common parent, that's something pretty common in web applications. You do a select which does some sort of filter. Now, this is optimized for the single, let's say, single child generation scenario. There are, if you want to do an arbitrary number of children in SQL, it gets interesting pretty soon. In Sling, you just get the children of the resource and process how many you feel like processing. And what's worth putting out here is that this is not just a Java API which nicely wraps some sort of arbitrary storage. As you saw earlier, these resources are stored in a way which is really optimized for path-based access, looking at the parent, looking at the children. And of course, people always ask, well, can we do queries? Because they are so used to them. And yes, you can do queries. So that's another simple SQL query where we have a search criteria, an ordering criteria. And below is an example of what a query can look like in Sling. This is an XPath query. It works against a specific resource provider. That's something worth mentioning, that queries are resource provider specific. There isn't yet a way of querying the whole repository using a unified query language. There are concepts being flown around, but nothing yet productized. So writing resources looks just as you would expect them to look if you're using a data access object. You have some create, delete calls. It's all fine as long as you call commit. Editing resources is something slightly different because you can actually change the resource itself, as we'll see later. So we know the whole Sling jargon. We know how to use a resource resolver. how do we actually get to writing some code? And that's the way a servlet rather looks like. You annotate it, there's a special Sling servlet annotation, you extend one of the top level servlets and then implement the method that you would want to be invoked. The request and response are there. You can see that it's getting called for post methods and that it handles certain kinds of resource types. Coming back to the idea that you handle sort of resource types, you have special handlers for each resource type. And reading data is pretty transparent. You have the request, which already has the resource that you care about. And typically, Sling has made sure that that resource exists, that you have the right to access it, and all of these sort of side constraints that you don't want to handle in your script. You just want to handle what you have to do in your script or servlet. So there are two ways. The first one is getting a value map. A value map is basically a hash map of string to object. And for most applications, this works fine. You have this sort of non-structured evolving schema, and you don't need to have, let's say, a very typed way of accessing it. And as a hash map, you can get stuff from it. You see here a property, a method invocation, which comes with a default. So if that property is missing, you get the missing value because it's convenient many times when you display that. On the other hand, sometimes you want to have your own objects in here. So Sling offers you the possibility of adapting objects, unrelated objects, one into another. A resource is an adaptable, which means that you can transform it into something else. In our case, the post class is a custom class from the application domain, which Sling has no knowledge of, but still we can transform into it. Let's take a closer look. So in this schema, the blue objects are from Sling's domain, the silver one is from the Java libraries, and the yellow one is from our own application domain. So there is no way these posts could be linked to Sling. What Sling does is allow you to register some components, some OSGi components, which know how to transform from object A into object B. If you register such an adapter factory, which knows how to transform a resource into a post, then you can get your object from a resource. Writing data, pretty much similar. If you want to write using a value map, you call put. If you want to write using your own custom post object, you have that. You write using setters on it. All is fine as long as you call commit. As long as you call commit at the end. And since we're here at how do you handle requests, and maybe some of you saw the web components talk from earlier, I'd like to tell you a little bit about how we do templating. In Sling, you have the possibility of using lots of template engines. You can use JSPs if you like that, but there's also options for Groovy, for Scala, Ruby, server-side JavaScript. But the one that I think is most useful for Sling applications is one called Sightly, which, if you look at the syntax, it's based purely on HTML with data attributes and custom, an expression language that should be familiar to most of you. And the way this looks is, if you take a look at the first line, there's a resource value map access looks for the property GCR title. If it doesn't find anything, then it outputs blog. The second one is including different resources. So you typically want your templates to be sort of composed. You don't want everything in one big template file. So that's what you do with data slide resource. Iteration is something which you do pretty often as well. So you have this data slide list call, which takes a parameter of list children, which are the children of the current resource. And finally, you have the possibility of using server-side helpers. this in JavaScript or Java, and you have this data slide use helper call, which invokes a server-side JavaScript helper, which is then called below. I think that's pretty simple and readable code. And one extra advantage is that Sightly being built purposefully for HTML is context-aware. That means that when you output a Sightly expression, it knows in which part of the HTML template it is and escapes it automatically. So for instance, in this helper excerpt call, I had to specify a content of HTML because I would like to say it's safe to output HTML for this call. Okay, second demo time. Barry is back. He is concerned, again, that we do not have statistics for our blog. Before I could say anything, he told me about this crazy new thing called Redis, which is a key value data store which has powerful primitives for getting data instead, sorting, counting, and stuff like that. So I set out and implemented the statistics using Redis. And I'm going to try to be a little bit brave here and show you how So this is the web console that comes with Sling. It comes from another project from Apache Felix and basically lists all the components that you have in your application. I already have deployed my component. I'll take the defaults. This is where I want my statistics to appear. This is where I want to my Redis server to be found. Once that is done, I will go back. And we have a live guest appearance from the blog statistics. Now, the implementation is rather simple. We have the factory for the resource provider. These are OSGi configuration properties. No rocket science here. We configure the component. This is the way to connect to Redis. Redis is the library. And then we produce a resource provider. Oh, I forgot to show you the data that I have in Redis. So these are the posts. The odd ones are the blog posts, and the even ones are the number of hits. So we have basically the same invocation with the Java API, and we convert these into a map keyed by path to score and wrap them in a resource. Now that resource doesn't do anything very special either. It takes the entries, and when asked for a value map, it returns them wrapped. And I would just like to be a bit more brave since everything went fine so far. We have some nice tooling for Eclipse. So I have a meeting with top management. I would like to show 10 times more blog posts. And there you have it, instant redeploy in Eclipse. And just to be sure, the statistics are output in the same consistent format when coming from Redis as well. So there's much more to Sling than this. It has full of features. I'm not going to stand and read them all. Suffice to say, it happens that by good design and through the fact that it uses OSGi internally, that we found out that it's such a good fit for NoSQL data source. Actually, we built it way before that. For something called a JCR, Content Repository for Java API, which is described by a couple of JSRs. And it's basically a persistence engine for content-driven applications, which has lots of the features that you would expect, that you saw earlier, but also versioning, observation, in-memory notifications of what happens in your application, full-text querying, access control, so native access control, so user repository, and applying access control entries to your repository. And if you think that working with Sling with these NoSQL data stores would be nice, it would be great for you to have to work with Sling in the default setup with Apache Jackrabbit Oak. We have just a little time to go through the buzzwords. REST, well, we saw REST. Sling consistently exposes resources over HTTP in JSON or XML format. Middleware, we saw how it works with various data sources, exposes them transparently. NoSQL, we had 3 NoSQLs. OSGi, it's in there. These are some resources. I will upload them hopefully today. And I am ready to take 2 questions maybe, if there are any. Okay, that was it then. Thank you.